Hi there, this is Dr. Tech introducing new features of the trace analyzer. So I have kind of reworked the whole thing to make use of a feature called array formula, but that's kind of besides the point. So what I did was I added a few columns. Okay, so particularly column M to column P are particularly useful. All of the other columns can be useful too, but they're not going to be as directly useful as these four. So what these four columns are for is column O is for execution. So column O basically tells you at what location we are executing instructions. It's following the program counter. So when you see an entry here, that means we are starting at location 0, and then we go to location 1, location 3, location 5, and so on. So these locations are particularly important because they correspond to in the assembler. If you go to either the assemble tab, where you have lots and lots of details, or you can go to source and debug tab. So when you go to the source debug tab, these are the locations of the instructions. So when you look at these, then you can say, okay, so let me give you an example here. So in the trace, so let's just go down here, and you can see that this one is at location 2F. So when you go back to the assembler, and then you try to say, okay, what is at location 2F? And location 2F is right here. It is the LDI instruction. So it's LDI 21 plus is corresponding to that location. So when you have both of these spreadsheets open, you can cross-reference and understand how your program is executing. So that's the significance of column O. Column M and column N, respectively, are for tracking memory write and memory read operation. Column M is for RAM write operations. So you will see an entry like this when there's a write event to the RAM module. And this particular thing, I make use of the C dereference operator. So what this means is location FA is now changed. The content at location FA is changed to 0, 1. Okay, so that's a single equal symbol, which is the assignment operation, and this column is for memory write operations. The next one, or column N, is for memory read operations, which can be misleading sometimes because sometimes it is actually corresponding to the reading of an instruction itself, and other times it is corresponding to actual read operations from the stack. So what you need to do is to look at each entry, and you can see that each entry has is in this form star fd equal to 0, 2 in this case. So what that means is it is reading location fd, and the content at location fd is 0, 2 at this particular slice of time. So if you track, how your program is reading and writing in memory, especially when it comes to stack locations, basically the stack goes from FF and down. You can actually see how your program is utilizing the stack, and that can be very helpful when you're debugging your program. So now we have talked about columns M, N, and O, and then here's column P. So column P is also kind of interesting because it tracks how your program is changing the registers, the 4 registers in the register bank. And you can see that each one is quite simple. It just says column register B is now updated to 0, 1, or if you go down here, this one says the stack pointer column D is updated to a value of FA. Now, when you update the register, especially the stack pointer, sometimes it is useful to find out what it was and how it is changed to the new value. So that you can use columns QRST to refer to the previous value. So when you look at these two, then you know that the stack pointer was changed from FB to FA, so it was decremented by 1. So that can be really useful when you're debugging your program because you can now find out how your code is changing the stack pointer, and you can also compare the stack pointer at the entry point of a subroutine versus the exit point of the subroutine. It should be balanced, before you pop the return address. So if it is not balanced, then you know that you forgot to clean up something, or you accidentally moved the stack pointer when you're not supposed to. So all of these are new features in the trace analyzer, which is already in the processor folder. So I strongly recommend that you make use of this. And the way you use it is kind of talked about in previous lectures already. You go to sheet 1, you go to the first cell, and then you go to file, and then you specify import, and then you use upload, and then you get to your TSV file that you capture when you run the program inside Logisim using the command line. So in this case, mine is called Hanoi.tsv. So you specify the tab separated file, and it will upload it. And then it is very important that you select replace current sheet, but not the spreadsheet itself. So the fourth option from the top at this point is what you want with import location. And the second one, you want to use a tab as a separator. And then the last one, you have to specify no and do not convert text to numbers, dates, and formulae or formulas automatically. And then you click import, and that will update sheet 1. Sheet 2, which is what we just saw, is still updating here because it might take a little bit of time now because I have used a lot of equations to kind of get this to work. So it might take a little bit of time depending on your network connection and your processing power. But when it's done, it will give you this result, which I think is very helpful when you need to debug your program. It's better than setting breakpoints because if you set a breakpoint and the breakpoint is after a point of interest, then you would have missed what is happening when your program is executing. This gives you an entire trace of exactly what is going on when you execute a program, so it's particularly useful. The one thing that it doesn't do is it does not track cumulative write operations to the stack. So when you see something like this, it might be helpful to kind of write it down on a piece of paper and just remember that location FB now has a content of 19. So then when we have additional updates like this, then you also update on the stack and say location FA now has the content of 01. So there's no easy way for me to track stack read and write operations. I mean, I could probably do that, but it's not going to be easy. I will have to write some Google script in addition to a spreadsheet formula in order to get it to work. So that's basically the the whole thing. And to generate the TSV file, we have already talked about that in the past. So that method still works. I haven't really changed that particular aspect of running and debugging a program. There's only one extra thing that I want to bring up here, and that has to do with if you want to use this approach of writing a program, you really need to have a no op instruction as the very, very, very first instruction, because otherwise, for whatever reason, the first instruction, especially if it takes 2 bytes, is not going to execute correctly. So just make sure that you precede in the entire program with a single no op instruction at the very top, and that resolve that particular issue. Alright, so I'm gonna stop the recording now. I hope this is useful to you.